tendinous cords here, so they hold the valves in order to prevent them from opening again, because we don't want regurgitation. That means that the blood flows back into the atrium again. We want it to flow to these arteries, and these tendinous cords, they are held by the as you can see, papillary muscles. And so we also have the pacemaker around here. This is a node. It has an intrinsic rate. That means nobody gives that pacemaker some orders. It will depolarize about 90 times per minute. You know, this lup-dup, 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 generating electrical activity, and the activity is distributed over here through the atrium. You know, it's going to get a kick, but it will stop here because we don't want the whole heart to just, you know, have some activity. We have this atrioventricular ring here, you know, the valves, all of these valves that are in there, and they do not, they consist of collagen and fiber. So this fibrous tissues, they do not conduct electricity, which is really good. So this is insulating. We only get the electrical activity from the pacemaker here, and the two atriums give them a kick. And we have this semilunar, the semilunar valves here. And in between these two valves, we have the atrioventricular node, and this spontaneous depolarization rate is lower than the sinoatrial node. This is the pacemaker. And so it will cause the atrium to contract, but it will stop at the AV ring. Then it will go down to the AV node. It collects the impulse, and it's delayed by about 40 milliseconds. This is useful because that gives the blood time to get to the ventricles. Then the AV bundle, or the His bundle, will transmit the impulse down through the cardiac septum. You remember, that separates the heart, into the right and left branch, down to the cardiac apex, bottom here, and the smaller fibers take the impulse to the ventricular myocardium, the Purkinje files. So there is an electrical conduction. They will conduct this electrical activity towards the contractile myocytes, and that causes them to depolarize, which then causes contraction. So we have this again, and this impulse is carried up to the ventricular myocardium on both sides, and the chambers contract and the septum goes up, squeezing the blood in and up, and that increases blood pressure in the ventricles, and this is now targeting the blood into the arteries. So with a kick, and after 40 milliseconds, a twist.